Okay, so this problem is asking us to use the graph to find all the values for where x equals to y equal, or for values of x when y equals to 0 for the given equation. Write your answers in the form of plus nk, where n represents the interval between successive solutions. So if you notice, this is like you can look at this as a sine graph, and it makes sense because if here's your middle, then here's your high, middle, low, middle. So you can kind of see the like one cycle, and it's just going to repeat. So the very first thing I notice is there's an answer and there's an answer. So I can write my answers as x is equal to -1. And then my next answer is x is equal to 3. And then if you kind of draw this out, right? Where would this number hit here? Like, what would this value be? And if again you draw this out here, what would that value be, right? Sorry, it went too high on that and it doesn't look like a sine curve, but that's okay. So my point is, where are these numbers here? So according to this, I could figure out that because the distance between here and here is 4 units, right? The distance between here and here is 4 units, right? That means the distance between here and here is going to be 4 units. And here is going to be 4 units. So that basically means my answer, it could be -1 plus 4k, where k is any number I want it to be, an integer, positive or negative, whole kind of numbers. And I will just add -1 to it. So if you think about this, this is kind of like your slope intercept form, right? Where -1 is your initial value, and you're adding your kind of like your slope to it. Every 4 units, you're going to get another solution. So 4 units, solution. 4 more units, solution. 4 more units, solution. So that is the answer, -1 plus 4k. Now you could do, if you wanted to, you could have put 3 plus 4k. Why does 3 plus 4k also work? And technically, if you want, you could put a minus down there too, but because k is an integer, I'm taking care of all of those numbers. So 3 plus 4k could also be a solution, because then if I wanted to get to -1, I would just make k -1. That would be 3 minus 4, which would be -1. And then I've gotten my solutions. So when you're looking at a graph like this, you're always going to look for how far in between each of the solutions is it. And that's what they're talking about right here, where they say the interval between successive solutions. So it's just an interval of 4 units. Every 4 units, I have a solution. 4 units, solution, boom. 4 units, solution, boom, right? So that is number 15. Number 16 says, use the unit circle to explain the solutions you found in problem 15. Okay, so it's asking us for, if you remember the equation, it says when it's equal to 1. Wait, sorry. Sine of pi x over 2 plus 1. Like, when is it equal basically to 0, right? So we know that the graph of this period is 4 units, right? It's 4 units because of this 4 that we found right here. This 4 that we found right here, 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 and here, right? So we know that it takes 4 units to go all the way around the circle. Okay. When x is -1 is the first time that we find our solution. Does that make sense? So where is x -1? Oh, it's right here. So here's x is -1, and here's our solution. And then it equals to 0 again at -1 plus 4. So at x is equal to -1 plus 4 units, right? So in the unit circle, when y equals to 0, and when x is equal to -1, you can rotate that from the point around the unit circle and get a full rotation back. So you can go this way, go a full rotation, and then you're back there at -1. Now, technically, because we were adding and subtracting, you can go in this direction as well. You can get back to the solution. Basically, they're asking, when is it equal to 0? Okay, so it takes a full rotation to go back to that point when x is equal to -1. So this is why my preference was to write our answer like this, because that 3 would have been funny, right? You're like, what does that 3 actually mean? So if you think about, like, if you want to go with Ferris wheel, remember Carlos and the Ferris wheel? It takes Carlos 4 seconds to get back to F. Get back to F. Okay. All right. Hopefully that makes sense. Have a great day. Bye. So I'm adding to this video after I stopped recording because I thought it would be beneficial for you to see this done algebraically so you can kind of compare and contrast your answers. So I'm going to solve this one over here. And it says sine of pi x over 2 plus 1. And we're looking for when y equals to 0. So I'm just going to set this equal to 0. Okay. And so the way that we've talked about solving these is we basically use SADMAP. SADMAP is PEMDAS backwards. And so I'm going to look for any subtraction or addition on the x side. Now, in case you're wondering, okay, Ms. Johnson, where does all that stuff in sine go? It goes inside parentheses. Okay. So first thing I'm going to do is subtract 1, which makes sense. So I get -1 equals to sine of pi x over 2. And you're supposed to, and then I'm pretty much done with SADMAP because now I'm going to use what I know about trig to do it. So the very first thing I think about when I think about sine being -1, I think about down here. Because sine is y, and y is at -1 at the bottom of the unit circle, which is 3 pi over 2. So this angle here is 3 pi over 2. So I can say that all of this stuff in here equals to 3 pi over 2. So pi x over 2 equals to 3 pi over 2. And you can kind of play matching if you want, because then you'll see what comes out, or you can algebraically solve this, whichever one. I like playing matching. So since this 2 matches this 2, and this pi matches this pi, it must mean that this x equals that 3. Okay, so in case you don't believe me and you're like, no, Ms. Johnson, solve it. So then I would multiply by 2 and divide by pi. And do you see how pi's divide and 2's divide? So I'm left with x, right? So I'm going to do that same thing on this side. And notice the pi's and the 2's, they divide out. So x is equal to 3. Okay. But I forgot to do this whole thing where I do this guy equals to this guy plus 2 pi k. So now I'm going to multiply by 2 over pi to this guy 2. And notice your pi's cancel, and you get 2 times 2, which is plus 4k. And if you're looking, you're like, hey, Ms. Johnson, those answers are the same. You said you preferred that -1. I do, but if it comes out that way, it's okay. And that has to do with where sine lives, or like in the graphing calculator, it'll always output anywhere from here all the way to here, right? It goes from -1 to +1, right? So that's where, or whatever. Yeah, it goes from, negative pi over 2 to pi over 2. So you can also, I could have written right here, instead of writing 3 pi over 2, I could have written negative pi over 2, which would have given me my answer of -1. Okay, so either way, these answers are all, I know they look different, but they are all actually equivalent because of the nature of our periodic sign, right? Okay, now I'm finished. Thanks for listening again.